नमस्कार दोस्तों, वेलकम। आज हम देखेंगे महाराष्ट्र स्टेट बोर्ड 12th केमिस्ट्री प्रैक्टिकल सॉल्यूशन एक्सपेरिमेंट नंबर 1. So let's start. Aim to determine the concentration in terms of molarity of KMnO4 by titrating it against a standard solution of oxalic acid. So the first question is, the molar mass of oxalic acid is, and these are the options. So the correct option is option B, that is 126 gram per mole. So here is the explanation for this answer. We know that the molecular formula of oxalic acid is H2C2O4 dot twice H2O. So the molar mass of oxalic acid is equal to 6 into molar mass of H atom plus 2 into molar mass of carbon atom plus 6 into molar mass of oxygen atoms. In this formula, we know that there are 2 carbon atoms are present, 6 H atoms are present, and 6 oxygen atoms are present. So again, we know that the molar mass of H atom is 1 gram per mole, molar mass of carbon atom is 12 gram per mole, and molar mass of oxygen atom is 16 gram per mole. So the molar mass of oxalic acid is equal to 6 into 1 gram per mole plus 2 into 12 gram per mole plus 6 into 16 gram per mole. By doing the calculation, we get the molar mass of oxalic acid is equal to 126 gram per mole. So the next, to prepare 1 molar solution of oxalic acid, and these are the options. And the correct option is option A, that is 126 gram of oxalic acid dissolved in distilled water and diluted to 1 liter. So here is the explanation for this answer. We know that molarity M is equal to number of moles divided by volume of solution, which is in liter. We know that number of moles are nothing but mass divided by molar mass. So molarity is equal to mass divided by molar mass into volume of solution. We have molar mass of oxalic acid is equal to 126 gram per mole. Molarity of oxalic acid is equal to 1 molar, that is 1 mole per liter, and volume of oxalic acid is equal to 1 liter. So by adding these values in the given formula, we get 1 mole per liter is equal to mass divided by 126 gram per mole into 1 liter. This is the mass for oxalic acid. This is the mass for oxalic acid. So by rearranging the equation, we get mass of oxalic acid is equal to 1 mole per liter into 126 gram per mole into 1 liter is equal to 126 gram. So to prepare 1 liter 1 molar solution of oxalic acid, 126 gram of oxalic acid dissolved in distilled water and diluted to 1 liter. So next, water of crystallization present in oxalic acid is R, and these are the options, and the correct option is option B, that is 2. This is the correct option. We know that the molecular formula of oxalic acid is H2C2O4 dot twice H2O. In this formula, we have seen that there are 2 water molecules are associated with the oxalic acid. So water of crystallization present in oxalic acid are 2. So next, oxalic acid is used to prepare standard solution because it is a, and these are the options. So the correct option is option B, that is primary standard substance. So next, The quantity of oxalic acid required to prepare 0.1 molar 100 ml standard solution of oxalic acid is, and these are the options, and the correct option is option C, that is 1.26 gram of oxalic acid. So let's see the explanation for this question. We know that again molarity M is equal to, that is mole per liter, is equal to mass divided by molar mass into volume of solution. So we have molar mass of oxalic acid is equal to 126 gram per mole. Molarity of oxalic acid is 0.1 molar, that is 0.1 mole per liter, and volume of oxalic acid solution is equal to 100 ml, that is 0.1 liter. So by substituting this value, we get 0.1 mole per liter is equal to mass divided by 126 gram per mole into 0.1 liter. So by rearranging the equation, we get mass of oxalic acid is equal to 0.1 mole per liter into 126 gram per mole into 0.1 liter, that is equal to 1.26 gram. So the quantity of oxalic acid required to prepare 0.1 molar 100 ml standard solution of oxalic acid is 1.26 gram. So next are the short answers question. So first question is calculate the molar mass of oxalic acid, and given that molar mass of H atom is equal to 1, molar mass of carbon atom is equal to 12, and molar mass of oxygen atom is equal to 16. This value you very well know. So answer, the molecular formula of oxalic acid is H2C2O4.H2. So molar mass of oxalic acid is equal to 6 into molar mass of H atom plus 2 into molar mass of carbon atom plus 6 into molar mass of oxygen atom. So by adding or substituting these values of molar mass of H, C and O atoms, we get molar mass of oxalic acid is equal to 6 into 1 gram per mole plus 2 into 12 gram per mole plus 6 into 16 gram per mole, and by doing the calculation we get the molar mass of H2C2O4.H2, that is the molar mass of oxalic acid is equal to 126 gram per mole. So next, why heating is required in oxalic acid and potassium permanganate titration, and here is the answer. The reaction between oxalic acid and potassium permanganate is very slow at room temperature. So high temperature, that is about 70 degrees Celsius, increases the rate of reaction. Hence heating is required in oxalic acid and potassium permanganate solution titration. So next, why one test tube of dilute sulfuric acid is required in permanganate titration? So here is the answer. We know that KMnO4 is a strong oxidizing agent. In a neutral or alkaline medium, it decomposes into manganese dioxide, that is MnO2. Hence, to prevent decomposition of KMnO4 into MnO2, dilute sulfuric acid is required in permanganate titration. So next, what is the oxidation state of carbon atom in oxalic acid after the completion of redox titration? So answer is +4. The oxidation state of carbon atom in oxalic acid is +3. After the completion of redox titration, it is oxidized to carbon dioxide, that is oxalic acid is converted into carbon dioxide, and in oxalic acid the carbon atom has +3 oxidation state, which is after the completion of redox titration it is +4 in carbon dioxide. So the correct answer is +4. So next, why primary standard substances are used to make standard solutions. So primary standard substances are used to make standard solutions because primary standard substances are highly pure, have stable composition, they are non-hygroscopic and have high reactivity. So due to these factors, primary standard substances are used to make standard solutions. I hope you like the video. So thank you.